Hello everyone, my name is Greg and I dev stuff. Welcome everyone to the first episode of Yakuza-like game in Unity. In this series we will be making a game like the Ryuga Gotoku series, or more widely known in the West as Yakuza series. My main goal of this tutorial series is to implement the brawling combat mechanics and the open world of the game in style of Yakuza games. This series is brought to you by generous support of people on Patreon. If you want to join them, link to my Patreon in the description. After downloading and installing Unity, we will have to select the preset which we will use for creating a new project. While this tutorial will work on any rendering pipeline of Unity, because it will most likely deal with the gameplay side of the implementation, we will be using URP as a template for our game. URP will give us tools to achieve better graphics, while being compatible with majority of available devices. HDRP can achieve better graphics, but it is much more demanding for the hardware, which can limit the reach of this tutorial. I want you to be able to make game for any kind of platform rather than being limited to gaming PC or modern consoles. After we create our project, you will see something like this. First, let's clean this up. Delete readme and tutorial info folder. Then, let's create our new scene. Let's call it main scene. Save it by pressing Ctrl S and put it into the scene folder. Let's move the sample scene and sample scene lighting setting into this example assets folder. Good. Now we want to import a bunch of assets we will be using in the game. First, let's import Cinemachine. Click on Windows and open Package Manager. Inside, search for Cinemachine. Don't forget to select Unity Registry. Press Install. Wait until Unity installs the package. Then we need to find and use some kind of character model. Open the Asset Store. And I found this basic motion free asset by Kevin Iglesias, added to our project. So we are done with basic preparation. Now let's start actually implementing our character and camera into the game. Create a plane for the floor. Now let's create a new material. And assign a checkerboard texture to it. we actually can increase tiling to make the floor appear checkerboarded. Open the imported character and let's put the character on the scene. This is normal. This purple material thing means that the character material is set in a wrong way. It is for the older renderer, while we are on the URP. Let's fix this. Select the material in the project, which we have to update to URP. In that case, it is Basic Motions material. Click on the Edit, Render Pipeline, URP, Upgrade selected material. We will use Cinemachine to manage our camera. Click on the Cinemachine on the top and create Free Look Camera. Create a container for the character called Player. Attach the player model to this container and nullify positions. Then set follow and look at to follow and look at the player. You will be surprised but this will work now. But the positioning is pretty bad. So let's fix this. Scroll down and you will see top rig, middle rig and bottom rig. This option will allow you to allocate the area the camera will be moving around our character. Height represents the position of the camera on the height. The radius is the distance from the character which camera will be keeping. If we launch now, you will see that our camera is looking at the legs. Let's change that by changing the tracked object offset on the detailed rig setting. Make it somewhere on the head level of your character. Good. Now let's create an animator controller for our character. Create animator controller for our character. Reference it on the character animator. Now open the new window called Animator in the Animation category. Then create a blend tree for our movement. And assign 3 animations to the blend tree. Blend tree allows us to blend between animations based on the parameters of the animator. So if our character is standing still, our locomotion parameter will be 0. Then our blend tree will play the idle animation. If our character is running, locomotion will be equals to 1, and our blend tree play run animation. And in between we have a forward walk animation. Now we want to move the player around. Select the container. Let's add rigid body and capsule collider. Adding a rigid body component to an object will put it motion under the control of Unity's physics engine. Even without adding any code, a rigid body object will be pulled downward by gravity and will react to collisions with incoming objects, if the collider component is also present on the object. Let's change the placement of the collider. And freeze rotation on the rigid body. We will be rotating the character in the code. Create another new script called player input. This script will be responsible for reading the player input. Inside, create a new public variable called moveVector of type vector2. And in the update, read the horizontal axis and vertical axis. Pay attention that it is case sensitive. We will replace this with a new Unity input system in the future, but I will dedicate to this system a whole episode of its own to explain it in a more detailed way, because it is a very important topic. Now let's launch the game, and as you can see, if I press WASD on my keyboard, it will change the move vector. Actually, let's rename it to the move input. To mass rename something, press Ctrl RR. While we are here, One of the issues I have is that it is very uncomfortable to control the game when you have a mouse on the screen, going all over the place, when you're in the play mode. We want to hide the mouse, because in our game we don't need the mouse cursor on the screen. To do that, on the start, we want to lock the cursor inside the window of the game by calling cursor.lockState and assign locked state. Then we want to hide it. Good. When you are done, you want to press escape to show cursor, so you will be able to exit the play mode. Or you can use a shortcut, Ctrl P. It will start or it will stop the game if pressed. Good. Now we have an input from the player. We need to process it and move player according to the input. Select the player object and create another new script called locomotion. We will have to store the reference to the rigid body, so create a private variable of type rigid body. Store the reference to the rigid body on the start. Because our locomotion cannot work without rigid body, let's add the required component rigid body. Then we need a player input reference. Store the reference on the start. Good. Now create a new method called handleMovement. Inside the method, we will read the player input and create a new variable called moveDirection. Then use the camera forward as our direction to move. And multiply it by the vertical move input. This will make our character move towards the direction the camera looks. Then we will multiply the right vector from camera by the X move input, which will represent the left and right movement for the character. Let's nullify the Y rotation because we don't need the up and down rotation. And normalize our move direction vector. We need a variable for our speed of the character. Create serialized variable called movement speed with default value of 5. Multiply move direction by move speed. Then apply physics gravity to our move direction. and apply the move direction to rigid body velocity. Now we need to call handle movement from the fixed update. Use fixed update for anything related to physics. Before we launch in the editor, remove Use Gravity checkbox. We don't need it because we are applying gravity through the code. Then set Interpolate to Interpolate. This will remove choppiness in the camera tracking, because the camera operates on the renderer frames, which is faster than physics frames, which will cause object which is being actively tracked by the camera feels like it has some weird choppiness in the motion, because object will be changing the position on physics frames, while camera is tracking on the rendering frames. Now launch the game. We can move forward, but it has a weird thing about moving left and right. To fix this, we need to change the binding mode on our virtual camera to world space. If I lift my finger off the button, the character slides a little too much. To fix this, let's actually use getAxis raw instead of getAxis. If you use getAxis, Unity will apply its own smoothing and gravity to the button. It is not a bad thing, but for the movement, in my opinion, in our case, it is easier and more convenient to just use raw input of the axis. Plus, we will replace this part later on with a new Unity input system. Good, now let's rotate our character into the direction he is moving. Create new method called handleRotation in the locomotion script. We will be using a new variable called rotation direction. Now let's calculate the rotation for our character based on the rotation direction variable. First, recalculate the rotation vector into the quaternion by using quaternion look rotation. Then do slurp between the current rotation of the character and rotate towards quaternion. Apply the target rotation to our object transform rotation. Now we have to update the rotation direction with the direction we want our character to rotate towards. For now, we can simply apply the rotation based on the movement direction. We will be working with the rotation direction more extensively later on in the series. We can do that because we are applying the gravity to the move direction here, and this will cause our character to look down because of the gravity. Let's redo this a little. Let's store the calculated velocity into the variable. Then in the handle rotation, if the magnitude of the move direction is higher than 0, we will apply the move direction to the rotation direction. Magnitude of the vector is its length. So this will read something like if the character is moving in some kind of direction, apply it to the rotation direction. So the character will rotate towards the movement direction. Good. Before we move on, let's optimize this code a little. Doing camera.main.transform is expensive for performance, because every time you call camera.main, Unity will inefficiently search for the object with the main camera tag on the scene. So let's cache it into the variable. And let's cache our transform of the object. Good. If you know more tricks which I should do, let me know in the comments below. Now let's animate our character. Select the character model with the animator on the scene. Add a new script called character animator. We will be, of course, animating something, so let's immediately cache the animator into the variable. And add a required component. Then create public variable called forward motion. Then apply it to the locomotion parameter in the animator. come back to the locomotion script and create a new variable for character animator. And immediately cache the reference to the character animator. Then create a new method called handleAnimator. Inside, pass the magnitude of the player input, move input for the forward motion. Let's try this. Okay, this is working on the keyboard. But I only can run, so let's try to use controller to do small steps. So I just plug in my controller and it works, but you can clearly see that the character do steps as fast as he runs. This is happening because we are normalizing the movement direction. This will remove the angle at which your stick is being pushed. So you can't have this, fine control of your character. To add the ability for our players to adjust the speed at which his player is moving, we will simply multiply the target velocity by the player input move input magnitude. So let's launch it. But now, if I hold V and D at the same time on the keyboard, or V and A, it will combine them into the higher value than 1, and cause the character to run faster than he should. Let's make a property called forward motion, which will return the input magnitude, which will be clumped between 0 and 1. Okay, I know that the right stick doesn't work with the camera. We will be handling the camera later on in the tutorial. Before we wrap this episode up, let's do some work around the place. Let's hide the public properties you don't want anyone to see in the inspector. You should only keep properties visible if you want your game designer to interact with them. Any other public properties should be hidden by using hide in inspector attribute. The clear example of that is locomotions. You want to keep those properties public because you want your designer be able to play with them. You know, making character just a little faster or slower to test stuff and tweak the values. Good. This is it for this episode. If you have any questions or any ideas about code, please leave your comment below. If you are interested in seeing what will come out of this, please subscribe. If you want to support further, you can find my Patreon in the description. Special thank you to Cameron Smith for his generous support. With best regards, see you in the next episode.